Good morning. So, today it would be a sort of complete revision of whatever we discussed till now for the heart. So, that we'll be watching lots of graphics. And more or less, you can think like that it would be a sort of not only revision, but I'll be keeping few of the images which will be for your practice part, right? So, let's start because from Monday, I'm planning to take the dissection all the way to finish the thoracic dissection by the end of next weekend. Okay, so let's start. Now today's session is like it might be a bit short, long, I don't know, right? It is the speed at which we'll keep on watching all the contents, right, of the graphics. So here it is, right? We start with the heart and we know this part that it was the manubriosternum that was called as the sternal angle, right? And that sternal angle, which is a junction of this, is manubrium, right? This one is manubrium, and then the sternum. So that one is the sternal angle. It is that angle at which we know this part that ascending aorta ends, arch of aorta starts and ends at that level, and the descending aorta starts, right? So that was one point. And the main thing over here is that this is the level at which the arch of aorta takes turn. That is the superior limit, and the base of the that is this base on where the heart actually sits on the diaphragm, that is the inferior limit. So this is the range of the heart from superior to inferior limits, right? Moving on to the next one. Here, as we watch it from the side, right? This is like our lateral view, right? That's our lateral view. And in lateral view, this is a view which is different than what we saw on the dissection, right? That was the left lateral view. This is we are watching it from the right side. So that's the reason what we are watching over here is this is the right atrium, right? That is the right atrium, and we have got the superior vena cava and the inferior vena cava opening into it. And here is the diaphragm, right? And the diaphragm which is giving the entry to inferior vena cava, and it is just coming out. That's what we saw, and straight away it enters into the heart. Rest is all good and known to us. Moving on to further one. This is what we haven't discussed yet, right? So that's why this part we'll discuss it a bit properly. And this one, it is what is called as the pericardium. Pericardium surrounding the heart. This is a layer, right? This is a layer which is covering the heart. It is divided into two parts. One, what is called as the fibrous pericardium, right? It is called as the fibrous pericardium, and second is called as the serous pericardium. Serous, right? Serous pericardium. Now, this fibrous is tough. So anything, if it is tough, though, it has to be outside. Yes, this is outside, right? This is outside, outermost. When it comes to serous pericardium, serous is that part which is related to the organ, right? So it is again divided into two parts. One, what is called as the like pleura, parietal pleura, and the visceral pleura. Same way over here, we have got the serous that is parietal serous, and the visceral serous pericardium. And in between, the way it was pleural sac, here we will be calling it pericardial sac. Pericardial sac, a space which is between parietal and the visceral layer of serous pericardium, right? This is what we need to remember. Okay, this, it has got functions. If you really talk about the functions, two major functions which we talk about. One, it would prevent friction, right? It would prevent friction because it is very properly covered within these layers. So though the heart is beating constantly, there would be very less friction with the surrounding structures. And second, it prevents overfilling, right? It prevents overfilling because this is a tough structure which is covering it, and when it is covering, so it prevents overfilling because it gives the resistance, right? So that's the pericardium. If we go below, right, over here, here it is attached with what's called as the central tendon, right? Central tendon of diaphragm. In diaphragm, we saw that, right? It was a central tendon. And this is the reason heart moves with respiration, because we know that the diaphragm, even during the quiet respiration, it is the diaphragm which helps in the movement of the respiration, right? So this is how it moves. So this is covering. Now if we look at other structures, right, very easy. This part is what that was epicardial fat, right? And we have seen this fat in the real dissection, right? So that's the epicardial fat. Okay, we remove even that epicardial fat. Once we remove that, this, right, that's the heart, right? And I think you won't find any problem in identifying the chambers, right? Gross chambers, which are they? Let's take it this way. This is in pericardium, right? So in pericardium, this outer one, this one would be the fibrous. Once we remove the fibrous, right, this is the second layer, this one where this P is written. So this is serous pericardium, serous. And in this P stands for parietal. And where is visceral? Visceral is something which is snugly attached with the heart itself, right? So combination of both is called as the parietal, that is the serous pericardium, parietal and the visceral. Visceral is snugly attached with the organ itself. Yeah, so just a sort of that which layer is this. Right now, you'll remember, but this is for practice, right? So I'll just put a star. This would be a for practice. So this arrow which is marked over here, this is the parietal, right? And this below one, that one would be the visceral pericardium, right? Part of serous. Okay. Now, here it is. Quickly we go through all the structures, right? So this is the left side, right? That is the left side. And in heart, over here, this is the right ventricle, right? That one, or let's write it here. Right ventricle, that is right ventricle, left ventricle. So this entire portion, right? Let's write it here. This entire portion, right? That's the right ventricle. What we see over here, right? This one, this is the left ventricle. And in left ventricle, this point, right? That is the apex. That's where we get that apex beat. Apex beat. Now, when we try to see on the top, there would be the first intercostal space, second, third, fourth, fifth, right? Fifth intercostal space. So this apex, that is in fifth intercostal space. Writing it separately because you have to remember it. It is fifth intercostal space. Do remember, right? Important point. Fifth intercostal space. Rest of the structures. This one is what? That is aorta, correct? That is aorta, and then the branches, etc. that will come, right? This one is the superior vena cava as it goes down, and this one would be the pulmonary trunk. We have seen these structures very properly, right? So we are moving ahead. Okay, here we have rotated it slightly, so without any hesitation we straight away know that this one is the right atrium, and on the top that would be the superior vena cava, and this one is the inferior vena cava. One interesting thing about it, this is, we'll see it today, that in inferior vena cava there is a valve, but in superior vena cava there is no valve, right? The blood straight away gushes into the right atrium. Over here, that would be the aorta, and this one would be the pulmonary trunk, right? Pulmonary trunk. At the end of today's session, right, I'll ask you a question that what do you really want? Say we have got the option that either we can start with ECG, right? So the ECG, that is where we'll be deviating to the physiology part of the cardiology, right? So we can do this, or we can continue with our dissection, right? And we move further, so all the way to heart. Heart is almost over, right? Then we'll go to lungs. So lungs are important, and then all the esophagus and thoracic duct and all those topics which are relatively small. So any of these things is possible. In ECG, though, we'll be requiring at least 2 days. Say like coronary angiography, that the way by the end of the session you were able to identify even that which artery is involved, where exactly is stenosis. Same way it should happen into the ECG, that on the first day when you'll be learning all normal things, right, and understanding it. Today also I'll be taking small part of ECG so that we can even take this topic. So you guys decide, you just let me know. ECG, they want ECG, I don't mind, right? We can go for that, right? But still, let's see what others say. Regarding this is right atrium and this one is right ventricle. Now, if I ask a question, right, now here is a question, and I am very sure that you'll be able to answer it. This one, this artery, these arteries, right? Can you name which arteries are these? Which arteries are these? Right? All those arteries, they are, that's right, coronary arteries. Obviously, over here, something what we see on the surface of the heart, it has to be coronary artery. But I would expect slightly more detailed answer. Coronary artery, okay, right? Coronary artery, it has to be coronary artery. But and it is on the right side between right atrium and right ventricle. So it is, yes, exactly right. It is between right atrium and right ventricle. So it has to be right coronary artery. But these are the branches because this is right coronary artery. This one, right? This one is right coronary artery, right? That main which is passing. Exactly, marginal and diagonal, right? These are something which is giving to the margins, the lateral margin of right ventricle. So yes, they are the marginal and acute marginal. That is true. So very good, right? So these are the marginal, and to be precise, we can say acute marginal arteries. Excellent, very good. Here it is. Now we go for another view, right? This is right atrium, right ventricle, right? Absolutely the lateral side, so that we can watch rest of the structures, and thus we can see that this one is the left atrium, and it is the left atrium where we see these two things. What are they? What are they? This one, they are, right, these structures. That's right, because these are the pulmonary veins, only vein in the living body which will be carrying oxygen, right? Because they are from lungs. From lungs, they are coming to pulmonary veins, and that's what it goes into the left atrium. From left atrium, it goes into the left ventricle. Here it is, another view, right? This one, this is a very typical view, as if we are watching from below, right? So this is what is called as the diaphragmatic view. The purpose of today's session is only one, to give you the absolute clarity on all the surfaces, that where exactly these chambers they really stand, right? So here it is. diaphragmatic view. So when we watch from below, this is where there is right ventricle, and this is where there is left ventricle, right? So it is these ventricles, they form the base right below. So that's right ventricle and the left ventricle. Okay, right, easy. Now we are on to the side, and this is right ventricle over here, and very clearly that's the left ventricle. From right ventricle, the right ventricle outflow tract. This is the right ventricle outflow tract. So there would be infundibulum, right? And this is the pulmonary trunk, right? Pulmonary trunk. Just behind, we can watch that aorta, right? That one is aorta. Okay. Over here, typical, right? Typical classical heart. So this is like we just take it for practice, and we have already talked about it, that those branches, right? Those branches, that was right brachiocephalic, brachiocephalic, and then it is dividing into, this is the right side and this one is the left side. So this one is a common carotid artery, right, which goes up, and this one would be the subclavian artery. Similarly, this one would be the right common carotid artery, and this one would be the subclavian artery, right? And things go over here. This will be going towards brain and head and neck, and the subclavian, that will go for the upper limb, right? Plus giving the branches for the chest, right? Those intercostal branches, and some branches, they will be arising from the aorta itself. Here it is, the right, see from the root, this is aorta, and we were telling that from aorta, right, from the root, the emergence of coronary artery. Here is the point from where the right coronary artery, right coronary artery emerges, right? So that's, and rest the branches, they are known to you. On to the next one. See, over here you are watching even the veins also, coronary veins also, right? So they also follow along the same pattern. Then this one is what? Right coronary artery. This you have already told me, right? There are two branches over here. In fact, three, right? So what is this one? What is this two? And what is this one? So what is one? What is two? What is three? One is what? One would be the left coronary artery, right? Then what's this two? Two which is going anteriorly, right? And it is between what? This is between right ventricle and the left ventricle, right? Yes, that's right. So this one would be the left, or we can straight away say ascending, anterior descending artery, right? LAD. LAD, right? So it would be left anterior descending. So you know this part. And the second one, which is going, taking a turn, and it is trying to go posteriorly, that would be the circumflex coronary artery, right? That is circumflex. To the next one. Just whole idea is that you just watch all these structures, right? Again, for practice. Yeah. Any comment on this? Right? This is what? If only this much is given, right? And it is asked, what is this? This one. What is this? Very good. Very good. Right? This is pulmonary trunk. Right? This is pulmonary trunk. This one is aorta. Right? Now what they have done in this case is, I'm just removing it and I'm zooming it. See, they have put the arrow, right? They have put the arrow like this, right? This is how the arrow has been put. So this arrow is indicative of that the blood is passing through it. If the blood is passing through it, so then what would you call it? Right? This is a graphic, right? This is a graphic, but what if it comes in the form of a question that identify the structure, what it is? And yes, there would be one option of ligamentum arteriosum, which would be incorrect. There would be the option of ligamentum arteriosum, and I am telling that which would be incorrect. This one would be called as the PDA. PDA stands for patent ductus arteriosus. Patent ductus arteriosus, PDA, right? Ductus arteriosus, yes, but it is patent because in fetal circulation, this channel is open, right? So that is what is called as the ductus arteriosus. But in the adult, if it remains open, so that is called as the patent ductus arteriosus, right? Why there is question mark on ductus arteriosus? Yeah, that is true. Means you are asking. Yeah, this is the answer, right? PDA or the patent ductus arteriosus. Okay. Now taking the inside. Ah, right. I got it. So this is now right atrium. In right atrium, the first look, two things which I want to show you extra, which we are not seen during dissection because it was not very evident. But over here, sometimes in graphics, you see the things more properly. In right atrium, the smooth portion, right, that was okay, but there is a rough portion above. This is the rough portion. And this is rough because of muscle, and they are called as the pectinate muscle. Pectinate muscle. So this is the first thing which is extra. And second, what we watch is, this is the IVC, inferior vena cava. This is superior vena cava. Superior vena cava is draining directly. For inferior vena cava, over here, there is a valve, right? There is a valve. So this is the valve which is for IVC. And in IVC, one more thing opens. And that is called as the coronary sinus. Right? Coronary sinus is what? Coronary sinus is where all the blood of the coronary veins, they are dumped over here, right? They come over here, and from here it goes into the IVC, and it goes, right? Okay. This one. So this is an oval fossa, right? So that's why this is fossa ovalis. Fossa ovalis, or also called as the foramen. That is, it was the remnant of foramen ovale, right? So this is the fossa ovalis or the fossa ovale. Rest is insignificant, right? The only important thing over here, right? This portion, I'm putting a star, right? So this is a septum, correct? So if we are watching at an angle, so on the opposite side there would be this is the septum, which would be between right and the left atrium. So that's why it becomes interatrial septum. And we'll see as we'll rotate, right? We'll see that how it goes into the right ventricle. That is where we'll see the valve. Okay. So here it is. Here is our valve, right? So just before the valve, right? I think we should draw it here, right? Here, yeah, right? That is like interatrial septum. Okay. This is interatrial septum. We rotate slightly more and we see this. So this is a valve, right? And this valve is none other than the valve which is between right atrium and the right ventricle. So it has to be tricuspid valve, right? And we'll see this valve in slightly more detail because we'll be able to see one more new structure which we were not able to see it very clearly during the dissection. So this is right atrioventricular valve, right AV valve, atrioventricular valve, or the tricuspid valve. We see it in more detail over here. Yeah. Same thing. This is just from the perspective, right? Say which chamber is this, right? Which chamber is this? This one. This is giving us the hint. Here it is. Here it is. Right? So we have rotated it completely and see these two are pulmonary veins, right? These are pulmonary veins. That means this chamber has to be left atrium, right? If this chamber is left atrium, so in left atrium, blood goes from left atrium to left ventricle. So this has to be which valve? It has to be bicuspid valve or the mitral valve, right? It has to be mitral valve, bicuspid. The point is not to be carried away by, Acha, this is tricuspid. So straight away we jump that, okay, this is also tricuspid. No, this is bicuspid. Watch from the hints which we are getting, right? Mitral hints which we are getting. Okay, looking further. Now see, we have taken out the anterior wall. So now we are watching right ventricle as well as the left ventricle. So that's where we see both the valves together. So this is our tricuspid. This is our the tricuspid valve, and this one is our mitral valve. Fine, right? So tricuspid and mitral. In tricuspid, there were three leaflets or the cusps, right? Three cusps. Those cusps were anterior, posterior, and third one was septal, right? Septal means that cusp which is attached to the septum, right? Which septum in between comes? That is the interventricular septum, right? That is the septum because this is right ventricle and this one would be the left ventricle. So this is septal. Regarding the mitral valve, there was more or less like anterior and posterior, right? These are the two cusps. And over here, there are three, right? So that you don't forget. And yes, this in between, this one would be the interventricular septum. Over here. Yeah, here we see something extra, right? And with much better clarity. In this, we are watching one, the valve cusps, right? I just zoom this. This is how the cusp is forming. This is what is called as the cusp, right? So these are like cup shaped things. These are cusps. These cusps, so this one, these are valve cusp, right? So they look like this. These cusps are attached with chorda tendineae, right? So these are chorda tendineae, cords like structure. These, so they are called as the chorda tendineae, right? Chorda tendineae. Then these chorda tendineae, they are attached to these muscles. So these are papillary muscles. These are papillary muscles. These are the muscles which will be connected to the wall. And in between, This is interesting. This one. That is called as the moderator band, right? The importance of moderator band will come. This is called as the moderator band. Now, who is moderator? Moderator band. Septum and septal? No, there is no difference. It's one and the same thing. Septum is also a layer. Septal is something which is attached with the septum. You can say like something which is associated with the septum. When we say, no, it says septal. Septal means associated with the septum. Septum is layer. So as such, from the language perspective, yes, they both are different. But otherwise, from the medical perspective, we can say septum is this layer, and anything which is attached to the septum, that is what it's called as the septal. See? So this is the moderator band, right? And this carry impulses to the small muscles of wall. So these are the moderator bands, right? They carry impulses to that papillary muscles, it is muscles of wall. Right? Do remember this. Fine. Achha. Over here, can you see such heavy musculature? Right? All those. That is what we say trabecula, right? Trabeculi. So these are trabeculi. These are seen in much better way as compared to when we saw it in the real dissection, right? So this is trabeculi. And contraction of trabeculi leads to contraction of heart. So that's why they are pretty tough, pretty important, right? So they contract heart. Okay. The next one. Same standard, right? All we see is right coronary artery over here. Rest of the structures, rest of the coronary arteries, they have been removed. This will be coming from the root, right? Aortic root to right coronary artery. Over here, see how nicely now it is seen so properly that where exactly we talk about. See here, this is the aorta, and from here it emerges. Right? It emerges from the root of aorta. So this is root. On the opposite side, yes, we have got the left coronary artery, and again its branches, right? But see how typically they are arranged. This is straight away, they both will be joining behind this appendage, right? That is the reason when we said that it is the left coronary artery, which would be between right ventricle and left atrium, and then it divides and then it goes posteriorly, and then there is circumflex and the whole thing starts. So we are watching it, this much is hidden, this much is hidden. We are watching this from this point onwards. So that's the reason that we have got two arteries, right? So this one would be the left LAD, now we know LAD, and this one would be circumflex. Circumflex branch, which will be of left coronary artery, which will be behind, right? As we'll be removing this, we'll be able to see that. Then these are the branches, these are small branches, these are small branches, right? They are, this would be the lateral side, so they will be the marginal arteries. Yes, that is right, right aortic sinus and the left aortic sinus, right? These are the marginal branches, right? Marginal branch. Marginal branches. Yeah. Seen with bit more of the clarity, right? So in this case, over here, the top one, right? This part. So this is right coronary artery branch, right? So this is marginal branches, right? And over here, something which is at the base, we are watching the diaphragmatic portion, right? So this would be the, as it takes turn, right? It is taking turn and it is going further. So over here, this is also called as the posterior. Now this is diaphragmatic portion, right? So it means we have got the right ventricle and the left ventricle. So this is also called as the posterior. This is also called as the inferior, right? Because it is over here. So inferior, yeah, interventricular branch. Right? That's right. Also called as the posterior descending artery. Exactly. Right. This is more or less for the practice. Right. So just put the mark. You have to identify that what is trabecula, what are cusps, what are chorda tendineae, what are papillary muscles, what are moderator bands, where is interventricular septum, which chamber, right ventricle, left ventricle, and the outflow track. That's it. Right. And it is easy. Yeah, in this, again, the same identification. Right? You have to identify chorda tendineae, you have to identify that where are the cusps. Right? All. Okay. Then, yes, again, identify these structures. Right? Identify this, identify this, this. Right? So moderator band, chorda tendineae, and just below these are the papillary muscles, and over there on the top they are the cusps. Right? So this is the clean images. I'm keeping it. It is for your practice. Yeah. Another point which we haven't discussed yet, and this is what is called as the coronet. This is called as the coronet. Coronet means it's sort of crown. Now these valves, right? These valves, these are the high pressure valves. So there is a fibrous ring. This ring, it is the fibrous ring. Fibrous ring over here. This fibrous ring, there is one fibrous ring for mitral valve, there is another fibrous ring for the tricuspid valve. So this is the fibrous ring, this is for the mitral valve. Mitral valve, right? And this fibrous ring, it is for the tricuspid. Right? So that's the fibrous ring. And rest of the structure, right? Collectively, this is, so this would be around the aorta, so it will be called as the aortic, right, coronet. This one, aortic coronet. And similarly, there would be, this is what we saw, fibrous ring of tricuspid valve, right? That's what we have already seen. Okay. Yeah, moderator band in between papillary muscle. So moderator band is what it is doing. It is supplying, see here. Yeah. See, it is supplying, it carries impulses to the muscles, right? Muscles of those valves. So these are all conductive tissues. So they control that how much current should really be going to these pulmonary muscles, these papillary muscles, well, not pulmonary, papillary muscles. So that's how they contract, depending upon the, say, moderator band, how much current it is allowing. So that's why everything remains under good control. This is the conduction system, right? So we have got the SA node, AV node, bundle of his Purkinje fibers, right? All of them. So that's the location. That's the location of SA node, sinoatrial node. Then there is another pacemaker which is over here. It is also called as the AV node, atrioventricular node. AV node, only one point is important, that this is the only window available between the top portion and the below portion. This is the only window available electrically, right? So if the current has to go from SA node to the ventricles, it has to pass through AV. It has to pass through AV node, right? So if a AV node block is there, that means these lower chambers, they won't be getting any supply, right? Then this leads to a bundle. It is called as the bundle of his. And this bundle of his, right, there is nothing like bundle of her, it is bundle of his name, right? And then the all the Purkinje fibers, right? These are the Purkinje fibers. SA node is our primary pacemaker, right? Because that is what it sets the rhythm, right? This one, SA node, right? Same images, just from different perspective. Right? From this point, we see this. This is just the very basic of ECG. In ECG, that's the chest, right? Here is the heart. You put one electrode over here. So if the current would be going towards this electrode, so there would be positive reflection. If it is going reverse, so there would be negative reflection, right? So if the current is going positive, it is going away, so it is negative. The entire ECG has got PQRST, right? It has got PQRST. Now, this P is the first contraction when the current is coming towards the electrode. So that's why it is jumping positive. When it is positive, right, what is happening? This is where it will lead to atrial depolarization. How much this atrial depolarization should last long? Matlab, it lasts up to this point, from here to here. And from here, from this point, there is the starting of QRS complex. So this is what is called as the QRS complex. Right, that one is QRS complex. This QRS complex represents ventricular depolarization. Ventricular depolarization, right? And then goes a small t1, and that small t1 tells that it is the ventricular repolarization. So where is ventricular repolarization, atrial repolarization? It happens. In some there are no Q waves, right? It all depends on, there are so many variations of this QRS complex. That is, we'll discuss at length when we'll be talking about ECG. But yes, there can be, and see, right now we are writing all these capitals, Q capital, R capital, S capital, it might be like QRS. So in this Q and S, they are so small, and it is the major contribution is from the R wave, right? So there would be all such notations, they will come. But that's why this is a very standard pattern, right? Very standard pattern. Yes, it happens that when some of the waves are missed, or when some of the distances they are increased, they are pathological. So it is from P, from the beginning of P to the beginning, right, over here, beginning of this QRS complex. So that is what is called as the PR interval. This interval would be crucial, right? This would be PR interval. PR interval. Then similarly, distance between S and T, the ST segment, right? This one, ST segment. And all the way from this point till the beginning of, till it ends, this whole thing is called as the QT interval. As we'll see more and more ECGs, this will become absolutely clear. If this is the condition, oh, okay, over here it is written only, right? So this one would be the right atrium, this one would be the left atrium. This is red, means it is the oxygenated blood, this blue is deoxygenated blood, but this blood is getting mixed, right? So over here it is coming via this small opening, right? It is coming over here, from here. So what are we looking at? We are looking at patent foramen ovale, right? Foramen ovale, which should be closed as the baby borns, baby takes birth, right? First cry and it closes, but else, because of the high pressure of left atrium, that blood pushes, it comes into the right atrium. So interatrial septum, gap, hole in the heart, commonest patent foramen ovale, right? What is this? This is one of the question, right? When it is asked, what is this? So what is this? This one. Yeah, ductus arteriosus, but make it complete, right? Ductus arteriosus patent, right? Add patent. Yes, exactly. So this is PDA. From this point onwards, we'll be calling it PDA, patent ductus arteriosus. Here it is. We are watching the complete ventricular musculature, right? See, this is a section, right? This is a complete section which has been taken, and just to show that this is, here it is, left ventricle, this one is the right ventricle, and see the ventricular musculature, right? Ventricular musculature. That is so thick as compared to this is right ventricular musculature, right ventricular muscle. Right? In between, we are watching is the interventricular septum. Fine. A very nicely seen aortic valve. Whenever there is myocardial infarction, right, it leads to this type of damage, right? MI. Today only I was watching one video. Some four guys, they were playing badminton, and suddenly one person got massive myocardial infarction, and within minutes he passed away. Within minutes. Young guys. and the speed at which these cases are increasing, that is phenomenal. Okay, a very nice figure, right? This you can use for the practice part because almost everything is seen. Say even the AV node, right? This one is AV node. See the fibers which are coming from the top between SA node and AV node. Interventricular septum, then right ventricle musculature, left ventricular musculature. These are the cusps. These are the chorda tendineae connected to papillary muscles. In between, you have got all those, let's say, moderator bands. Right. This is aorta, arch of aorta, aortic wall, right. And over here, this one is the tricuspid wall. So let's keep this thing for the practice. Keep it completely neat, and this one would be for the practice. Now you must have noticed, he is Indian. You saw that? Hmm. I put a kite, right? So tomorrow is the Kite Festival. You know? This is one more image. Yeah, moderator band, and they are seen very clearly. So much better image. So tomorrow is Kite Festival, right? So we won't be having any class tomorrow. We'll be meeting straight away on Monday, right? And we'll be starting with ECG. Is it fine? You want to start with ECG, right? ECG would take 2 days, and then we can continue with our dissection of thorax further, in which now we'll be focusing on the lungs. And in lungs, after the dissection, we'll be watching the pathologies of lungs, what can really go wrong. And these pathology will see under the light of radiology. That means we'll see the plain x-rays, CT scan, right, to, to diagnose it properly. And once these lungs are over, then all those small topics will pick up. Right, all those small topics, that is thoracic duct and sympathetic chain, etc. Right, that we'll see. Okay, so thank you so much. Right, do fly lots of kites. Right, and see you on Monday. Thank you so much, and bye bye. I'm putting this file into our folder.